Hey, hi people. So I did this contest today, 339. I was able to solve only 3 out of 4, and fourth I had an idea but could not solve it. I'll just explain the first 3 which I was able to solve. So let's start with first. So find the longest balance of a string of a binary string. So this was just fairly straightforward question. So the what approach will follow will be it will be a 4 step. First we'll understand the question, then we'll decide the approach. Third would be we'll implement, and fourth would be if something get wrong, we'll reiterate. Cool. So the problem was we were given a binary string consisting only of 1 and 0, and then we had to find the longest subarray which had initially let's say x number of 0, and then after that x number of 1. So the basically the requirement was to find a subarray something like this. So 3 0 and then 3 1, this will pass. But something like this 0 0 and then 1 1 0, this won't be count because all the zeros should come first, and then all the ones should be there, and the number of 0 and 1 should be equal. So this would be a valid subarray. So all the valid subarray we had to find the longest uh, longest balance substring. Substring. So this is fairly straightforward. What we can do, basically we can iterate on the string, and whenever we find consecutive zero, we just sort of calculate how many zeros are there, and then after that how many ones are there, and we'll need to take the minimum of these two numbers, because if one is the because we need to make it balanced, right? So we'll basically start in this string, and we'll count how many zeros are there, right? And obviously we need to have this condition so that it does not get out of bound error. And this would be a while loop, so this will break down whenever we find a 1, and then again we'll start counting how many 1 are there. Now what would be the answer would be a minimum of this 0 count and 1 count, and multiplied by 2. Why we are doing this? This would be again this would be because if we, let's say we found something like this where there was 5 1 and 3 zeros, so we will only take 3 zeros, right? And then we'll multiply it by 2 to get the total length, that is 6. And we'll take the max with the final answer, because at the end we want the longest balance substring. So yeah, so this should work. So this was quite simple, and this gave the correct answer in the first try. Let's go to the second problem. So in the second problem we are given some numbers, and we had to print a 2D array. Now what were the conditions? The first condition was all the numbers were within the range of, so let's say the length was from 1 to 200, and let's say if the length of nums was x, then all the element of this array would be from 1 to x, right? And the 2D array had we had to make sure that each row in 2D array does not contain any duplicate, right? Each row in the 2D array contains distinct integer, and also then we had to sort of minimize the number of rows in 2D array. So if you think a bit, what it's trying to do, it's basically, let's say it's what it's trying to do, the input array as in nums has given us some number, right? 2 3 4 4 4, then 5, then 6 maybe. Now when we'll try to form the when we'll try to form the answer as in 2D array, then you'll have to take care of the frequency of each element, because one row will contain only distinct element. So for example, these 3 4 cannot come in a single row of the final answer, right? So uh, let's say if we try, and also we have to minimize the number of row, right? So let's say the in our final answer, the first and we'll start picking from this input. So if we kept this one there, right, in the first row, now we cannot keep this second one, right? Because we need to, all the rows should have a distinct elements, right? So then we'll keep 2, now then we can keep 3, now then we can keep 4, then we can now again uh, even we cannot keep this 2 4, right? Then we'll keep 5, and then we'll keep 6. Now the second row would be, now one, there is one uh, left, this one is left, then 1 2 we have already kept, 3 we have already used, one there are 3 4s, we have only kept 1 4, so we'll keep 1 4 here, and then 5 and 6 again we have kept. Now again we are left with 1 4. So if you see this is a if you see the pattern, you will find out that we need at least how many rows we at least require. So we will require the number of row would be equal to maximum frequency of any given element in the input array, right? Because it's, let's say if the maximum any, let's say for the 4 the frequency is 3, then we would require at least 3 rows, right? Then only we would be able to accommodate these 3 4. Yeah, so the first thing which I did, I did this only. So I tried to find the max frequency. So what I did, I kept the count of all the numbers, right? And the size I kept 201, because the numbers is going to be from 1 to 200 only from the constants. Now I iterated in the input and increased the count of all the elements, and the max frequency would have been and I basically calculated the max frequency. So from this, what I got, that max frequency is of maximum frequency of any given element. So this why this was necessary, so that I can define my answer as in the final 2D array. So how many rows will be there, this max frequency, right? And then what I'll do, I'll just start putting all these input. So I'll start, so rather than iterating in this input, because I may get confused where to keep this and to get to track it. So what I did, either by iterating, I went into this count function, right? So count, what does count tell us here? So let's say this was the input, what would be the count here? We can maybe print here also. Let me print it for you, would be better. For int I is equal to I less than, let's say in our input only there are only we'll give this input only till 6 I plus plus, and we can sort of number of this is equal to count I. Let me paste this as an input, and if we'll try to run this, yeah, so in this input basically it's saying that there are 0 0, and there are total 2 1, as in 1 and 2. There is just a single 2, there is a single 3, and there are 3 4s. So the number of 4 is 3, number of 5 is 1, and again number of 6 is again 1. So we'll basically iterate in this count array, and we'll find what is the count of, as in ith element. So it would be count I, and now what we need to do, we just need to push so there are total this many as in current element. So we'll just need to go into these many rows. So this is what it's doing. So it's, let's say there are 3 4s, so it's going into 3 rows and pushing that element, so that we cover that element, and then we'll just return this answer. I hope this is clear. If no, uh, I hope this is clear. If no, I'll try to explain in a doc format or in description, or I'll add some doc. Yeah. So this was second, and then third was mice and cheese. So this in this there were 2 mice, right, and n different type of cheese. Each type of cheese should be eaten by exactly 1 mouse. So what and if the first mouse eats I cheese, so he would be getting reward I, and if the second mouse eats it, he would be getting reward 2, reward 2 I. So, and we had also given a non-negative integer k, and k was what, that the first mouse had to eat exactly k type of cheese, and the second mouse will eat how many, the remaining would be n minus k, as there are total n many cheese, right, n different cheese type of cheese. And we had to sort of minimize the reward points, right? So in this, if you try to understand this sample test case, so there were total 4 type of cheese, and so if the first mouse eats the first type of cheese, he'll get 1 point, 1 point, 3 point, and 4 point. Similarly, the second mouse eats these 4 cheese, he would be getting 4 points on the first cheese, 4 point on the second cheese, 1 point on the third cheese, and similarly 1 point on the fourth cheese. K was 2 in this test case, meaning that first mouse had to eat exactly 2, so second mouse also had to like eat all the remaining as in other 2. Now in this example, if we can see, it's beneficial to the first mouse eats the this and this, right? So he get 4 3 7 reward point. Now the third and fourth type of cheese has been eaten, right? So the second mouse only has option to eat the first 2, so he'll eat the first 2. So 4 4 8 and 7 from the first mouse, so total is 15. If you choose any combination, let's say for example, if the first mouse eats this and this, so it would be 4 1 5, then this mouse would be eating this 2, so it would be 5 point from second mouse, so the total would be 10. Also in this sample test case, it's given sort of, it feels like that you just pick the maximum, that will give us the wrong, although in this case it's working. I'll give you a sample test case, initiate it will fail. So let's say if we had a 4 type of cheese, right, 4 type of cheese, and for first mouse the reward looks something like, let's say 1 10 10 and 20, and for the second mouse it looked like something like 10 10 100 and 1000. So if we go greatly and see, and now also third input would be, let's say first mouse has to eat 1 type of cheese, that is k is equal to 1, k is equal to 1. So automatically second mouse will be eating 3 type of cheese, 3 remaining type of cheese. So if we go greedily and we just sort of give first mouse the highest reward point, or like highest reward 1, so what we are losing here, that the fourth type of if the fourth type of cheese is being eaten by the first mouse, then second mouse won't be able to eat this, right, because it has already been eaten by first mouse. But if you see the reward point associated with the second mouse on the fourth cheese is quite large, so it will always be in our like favor to like maximize the point, that we allow this second mouse to eat fourth. Okay, so this was just the simple observation, and so we sort of had to take care of this. And so initially it felt like db to me, but then a little bit of thinking, if you see it sort of it felt it's greedy. How it's greedy? That you assign a score to think like this: what will happen to my score if ith is eaten by first mouse instead of second mouse. So if first mouse eats it, I will get how many? uh, Reward 1 I point. And if the second mouse eats it, I'll get reward 2 points. So if I take the difference of this, and so this would be sort a good score, this would be a score. So higher this score, you sort of pick this first, because you are the difference, as in the second, if it's positive, right? So that means it's better to give that cheese to first mouse, right? And based on this score, you can sort this reward and pick the k highest score. Just pick the k highest scores in this array. So what I'm trying to say, let's say take take this one only, this sample test case which I have written here. So what would be the score for the first cheese? It would be -9. Right? For the for the second one, it would be 0. For the third one, it would be -90. And the for last one, it would be -980, right? So we need to pick k highest. K is 1, so we need to pick the highest of this one, right? So highest would be 0. So this says that you give the first mouse this type of cheese. So final answer would be, total points would be, first mouse will eat the second type of cheese, so it will come 10 points from there, and all other type of cheese as in will be eaten by second mouse. So he will eat this 10, this 100 and 1000. So this 10, then the third 100 and then 1000. So this would be our final maximum points, right? Why does this work? Because you don't want to take these negative values, like on this score layer, because in those cheese, it's better that the second mouse hits it. Okay, so this was fair, like quite simple to implement. uh, we had to sort of calculate the score, but then you also had to sort this, right? uh, because we won't be able to know, because we need to pick the maximum, right? If we sort this, it would be sort in ascending order, sorry, descending order. It would be, because we need to pick the first k, so it would be 0, -9 and so on and so on, right? So to basically what I am trying to say, during the implementation, I had to sort of take care of index also, as in this is a score for what type of cheese, right? So that's why I made a pair instead of vector of int, and then I iterated to all the n type of cheese. Then I calculated the score. A score would be reward 1y minus reward 2y, and this score is for the ith type of cheese, right? This is important because I need to calculate all the points in the end. So I calculated the score, I sort it, but this sorts in ascending order. I had to pick the first k maximum score value, so I sort of reversed it. This array, this just reverse the any given array in place, and then I calculated my final answer. So started, so I would be picking the type of cheese on the basis of this score array, right? A score array. So a score array, the first k maximum score. So I don't care about the score, I just care about the index. So for the first k, the point value would be as in the first k would be eaten by mouse 1. That's why I have taken the point from reward 1, and a score I dot second just denotes the index, what type of cheese this is, which we had kept handy at this time, calculating at the time of score. And once the first mouse has eaten all k type of cheese, then the remaining k type of cheese would be eaten by mouse 2, and that's why we would be taking reward point from reward 2 array. And this works, and this gave the correct answer, right? Now fourth I was not able to solve. I don't know if I was close. I had so basically I had got the pattern, but I was not able to implement the BFS. So basically this is maybe I'll get this correct, and then upload or upload a like short video for this. I'll give a hint as in what I'm thinking. Maybe I'm not very sure at the moment if it's correct or not. But so this was basically an in the input we are given a 0 some 0 1 array where only one position is 1 and all other are 0, right? And then there is a band array. So some let's not get into technical details. It's just that some of the positions are banned. Some of the positions are banned. And then there is a window size of k, that is we can reverse any sub array of size k given that this value 1 does not come to any band position. So considering for simplicity, let's say none of the position are banned, then what are the position we can achieve by reversing? So I'll just take an example. Let's this only. So if this this is the input array, I'll make it slightly non-uniform, and let's say k is 3. So if you see k is 3, initial position of 1, we can let's say pose of 1, it's what 0, let's say it's index, it's 0 1 2 3 4 4. Now if we pick these 3 and reverse it, you would be able to get this position at this one at 6, right? Positions covered, let's say covered means where we can take our 1. Our goal is to find the minimum number of reverse, so that to get 1 at any specified position. So we can get at this, we just reverse it, right? Position covered would be 4 and 6, and similarly we can get at this also if we reverse this, so it would be 4 6 2. If you take k5 instead of 3, you would be able to see, if you take these 5, you would be able to cover the position 8 also. If you take these 5, again you would be covering the position 6. If you take these 5, no change. If you take these 5, 3 to 5, you would be covering again the position 2, and if you take the first 5, you will be covering the position 2. So there, if you can see, there is a clear pattern. So in initial position was 0 1 4, and we covered basically 0 uh, so if the initial position was 4, we covered 0, 2, and after that 6 and 8, right? If so, a similar pattern uncovers in the in when the window is even, and basically, right, so there be a pattern, we would be able to cover plus 2 plus 2 plus 2, and we need to take care we need to take a corner cases if the input was this only, so we would won't have been able to like flip this, right, because there was no elements in the left side. So these are the corner cases which you need to solve. But you will get basically from starting from in the earlier case, starting from this position, starting position 4, you are able to reach either 6, 8, 2 or 0 in one flip, right? And if any of this was banned, we won't consider that, but otherwise it would be basically BFS. So starting from 4 we can reach here in one flip, then we'll start from 6 and we'll see what all index we can reach from there. So that would be 2, and basically this is the shortest path. Cool. So that was all. uh, Maybe I'll put like I'll try to do CP sometime with GitHub Copilot and compare or see how this performs. For today, I'll stop here only. uh, yeah, thanks.